Hi everyone. So right now we are going to start our COA group project presentation right now. We are from session 9 and our lecturer is Dr. Nur Haiza binti Abdul Wahab. For our group, Chun Yi will be the leader and I am Chen Jie, and we also have Jun Hong and Nazmi. So right now, let us move to the introduction part.
Hello, my name is Nazmi bin Karol, and this is the introduction to our project. Benchmarking, by definition, is the process of comparing performances between similar hardware or products. Usually, a computer benchmark is done by running a couple of tests on hardware to measure the performances of the machine. There are also different types of benchmarking, such as synthetic benchmarking, real-world benchmarking, and also application benchmark. Synthetic benchmarking is a type of benchmarking that is designed to test specific components of a computer under control conditions. The three main types of synthetic benchmark includes whetstone, lean pack, and dry stone. Real-world benchmark is a benchmark that simulates real tasks that users typically perform on a machine. Application benchmark, on the other hand, is a type of benchmark that uses specific software applications to perform the benchmark. The three benchmarking tools that we had chosen to conduct our tests are Geekbench and CPU-Z to measure the CPU performance, and Minito Partitioning Wizard to measure the read and write speed of the machine's main memory. This is our aim and our objectives. The aim of this project is to conduct this benchmark on 4 distinct computers, then compare and calculate the differences in terms of performance of the computers based on the finding of our benchmark test. Our first objective is run CPU-Z, Geekbench, and Minito Partitioning Wizards and the assembly program on the 4 chosen machines. Objective number 2 is monitor the performance of the machine CPU using Windows Task Manager under different loads. Objective number 3 is analyze and compare the findings to understand the CPU's strengths and weaknesses. And our last objective is to calculate and examine the CPU efficiency based on the time it takes for the CPU to obtain information and the CPU's elapsed time. This is the scope of our computer specifications. We have chosen 4 different types of computers. The first is Asus ROG Strix G16. It has a processor type of Intel Core i9 13th Gen, GPU type of RTX 4060 8GB DDR6, and then our second computer is Dell Latitude 5490 that has a processor type of Intel Core i5 8th Gen, also a GPU type of Intel UHD Graphics 620. Our third computer is Asus ROG Strix G15. It has a processor type of AMD Ryzen 7 6800H and a GPU type of RTX 3050 4GB DDR6. Our last laptop or computer is MSI Katana 15 B12V. It has a processor type of Intel Core i7 12th Gen with a GPU type of RTX 4070 8GB DDR6. This is the scope of our benchmarking tools features. The first one is Windows Task Manager. The Windows Task Manager, it provides the CPU information such as the name, cores, and logical processes, base speed, processes, and utilizations. Memory information such as the size, speed, and use and available memory. And then our second benchmarking tool, CPU-Z, it provides the processor's name, model number, manufacturer name, and cache level. It also provides the mainboard and chipset. It provides information about the memory type, size, and module specifications. It also provides real-time measurements of the CPU's core frequency and memory frequency. Thirdly, we have Geekbench. Geekbench provides system information of the machine such as the operating system, model, motherboard, and the power plant. It also provides CPU information such as the name, model number, manufacturer name, and cache levels. Another thing that it provides is memory information such as the size, transfer rate, type, and channels. It also shows the single core performance of the CPU and also the multi-core performance of the CPU. Our fourth benchmarking tools is the Minito Partitioning Wizard. This tool, it provides the read speed of the storage device used by the machine in sequential and random manner. The last one is the assembly program. this assembly program, it runs different amount of loops, and then it records the capture time and the execution time. And then this information can be used by us to estimate the CPU's ability.
This meeting is being recorded.
Good afternoon, doctor. I'm Chojuni. Now I'm going to present for benchmarking result of CPU Z for 4 computer models which are Asus ROG Strix G16, Dell Latitude 5490, Asus ROG Strix G15, MSI Katana 15, V12V. From CPU Z, the detail of CPU processors such as name, mass TDP, technology, number of core, number of thread, clock frequency, and also for the bus speed are recorded. Moreover, the detail of cache such as L1 data, L1 instruction, level 2, level 3 are recorded. Next, the detail of memory such as type, size, uncore frequency, DRAM frequency are recorded. Furthermore, the detail of motherboard such as bus specification are recorded.
This meeting is being recorded.
Next, for benchmarking result for Geekbench, the single core and multi-core score for each computer are recorded. Furthermore, in Geekbench, it also displays CPU info such as name, topology, base frequency, maximum frequency, L1 instruction cache, L1 data cache, L2 cache, and L3 cache. For memory info such as size, transfer rate, type, and channel are also recorded. For the benchmarking result of Task Manager, during the row root, the CPU usage, CPU speed, and memory usage are recorded for the row root. For the mirror root also same, the CPU usage, CPU speed, memory usage also recorded. For the high root, the CPU usage, CPU speed, and memory usage also recorded. Next, the benchmarking result for Mini2 Partition Wizard for Windows. There are two types of result, which are in test mode sequential and also for test mode random. So for the test mode sequential, we are going to record a transfer size for 32 KB, reading speed, writing speed, 16 KB, reading speed, writing speed, 8 KB, reading speed, writing speed, and also for 4 KB, reading speed and writing speed. For the test mode random, it's same like the sequential. Next, I'm going to present for benchmarking result of ASM code program for benchmarking software. So these are the result of 4 computer model for capture m-second before, capture m-second after, and their CPU elapsed time with different number of root, which are 50, 100, 200, 500, 700, and 1000. So that's all for me. Thank you.
This meeting is being recorded.
Okay, good afternoon, Doctor. I'm Chong Jun Ho. So I'm going to present the comparison, discussion, and analysis for the benchmark. So first start with CPU Z. So when we look at the processor, so Asus ROG Strix G16 used the Intel Core i9 13980HX, and for Dell Latitude 5490 used the Intel Core i5, and for the Asus ROG Strix G15 is used the CPU MB Ryzen 7 6800H, and for the MSI Katana 15 B2B, the Intel is used the CPU Intel Core i7-12650H. So for the number of core and threads, the higher the number, the faster the processing speed of the CPU and the greater the performance. So from the comparison, the Asus ROG Strix G16 has the highest number of cores and threads, and followed by the MSI Katana 15, then the Asus ROG Strix G15, and finally the least number of core and threads is the Dell Latitude 5490. So for the size of the technology, the chips, the smaller the size of the transistor, the higher the number of transistors can be fitted into the same size of chips. So which means increase the efficiency of the processor and deliver better performance. So for the size, the Asus ROG Strix G16 has the smallest size among all the laptop compared. So followed by Asus ROG Strix G15 and MSI Katana 15. Then the largest technology is Dell Latitude 5490, which is 14 nanometer. Okay, going up next, I'm going to talk about the clock frequency. Okay, so from the bar chart, you can see that the Asus ROG G16 has the highest clock frequency. Then is the MSI Katana, followed by the MSI Katana 15 B12V, which is a bit higher than the Asus ROG G15. Then the lowest clock frequency is the Dell Latitude 5490. Okay, so the higher the clock frequency is indicate the high clock speed of the CPU, which led to the faster processing, which means the greater the performance. Okay, so for the bus speed, okay, from the result, the Asus ROG Strix G15 have the higher bus speed, which is the 99.81 megahertz, followed by the other three laptops, which have 99.76 megahertz. So for the bus speed, the greater the bus speed, the more data can be transferred within a given time. So this means a faster communication speed between the components, which eventually will improve the overall performance of the CPU. Okay, next we'll look at the level 1 data and level 1 instruction of the laptop compare. Okay, so for the, you can see for Asus G16, it's got the L1 and L1 data and L1 instruction. Okay, for the L1 data, so it has 8 times 48 KB plus 16 times 32 KB, which is considered a medium association. The first one, the 8 times 48 KB, is the medium association, which offer a balance between speed and heat rate. And for the 16 times 32 KB is a high association, which is probably a higher associativity, which has a higher hit rate, but it has a more complex charge management. But by combining them together, a mix of medium and high associativity will provide a balance between the exact speed and the hit rate, which overall has a higher performance than the charge of the other laptop. Okay, so from the comparison, it's shown that the Asus ROG Strix 16 has the best L1 charge and L1 instruction, followed by the MSI Katana 15B12, then the Asus ROG Strix G15, and finally the Dell Latitude 5490. Okay, so for the level 2 and level 3, we'll see level 2 first. Okay, So when you look at the SSR District 16, it had 8 times 2 MB plus 4 times 4 MB. So it has almost the same explanation where the X times 2 provides a medium association of a balance between speed and hit rate, while the 4 provide a lower associativity, which still offer the substantial storage. So when the both of them combined, the mixed associativity will provide a more charge memory and high charge hit rate, which overall increase the performance of the CPU. So it's considered the best combination and the best level to charge when compared to other laptop. So from the result, we can see that the Asus ROG Street G16 has the best level to charge, followed by the MSI Katana 15 V12 and Asus ROG G15, and finally the Dell Latitude 5490. So when we compare the level 3 charge, you can see the Asus ROG G16 has the highest level 3 charge when compared to other, then followed by the MSI Katana 15, then ROG G15, and finally the Dell Latitude. So next we are going to look into the uncore frequency and the DRAM frequency. So from the bar chart, you can see that the Asus ROG G16 had the highest uncore frequency. Then for the second is followed up by the Dell Latitude 5490. Then the lowest uncore frequency is the Asus ROG Strix G15. So for uncore frequency, the greater the uncore frequency, the greater the performance of the CPU. However, the high uncore frequency will also lead to a high power consumption, where high thermal or temperature of CPU occur. Then for the DRAM frequency, okay, from the bar chart, you can see that the Asus ROG G15 has the highest DRAM frequency, then followed by G16, then Dell. So a high DRAM frequency will increase the data transfer rate, okay, which is crucial for the performance. But if the DRAM it should not be too high, since overclocking, I mean it can be high, but it can't be too high from a normal value, since if it's higher than normal value, if you're overclocking, it will cause the system instability, which led to the short lifespan of the RAM. Okay, so for the Geekbench, the single core score and the multi-core score of the laptops are compared. So for single core is to measure the processing power of single CPU core. So the higher the score, which means the greater the processing power of a single CPU core. So for the multi-core, is measure how efficiently the processor can handle the tasks that are optimized for multiple cores. So which means the higher the score, the greater the performance of the processor and the tasks that are optimized for multiple cores. So for the single core, Asus Strix G16 has the highest single core score, which is 2816, followed by the Asus ROG Strix G15, then MSI Katana 15, then finally the Dell Latitude with the lowest score, which is 1180. So for the multiple core score, the highest one is Asus ROG Strix G16 again, which is 15358, followed by the MSI Katana 15, then ROG Strix G15, then finally Dell Latitude 5490 again with the lowest multiple score of 3887. Okay. So here we will compare the base frequency for the laptop. So from the bar chart, you can see that Asus ROG Strix G15 have the highest base frequency, then followed by the MSI Katana 15, then ASUS ROG Strix G16, then finally is the Dell Latitude 5490. So the base frequency is the frequency at which the CPU run and the system load is light, or when the laptop is in idle. So which means the higher the base frequency result in a better performance. So for the maximum frequency, from the bar chart, we can see the highest maximum frequency is the ASUS ROG Strix G16, followed by the ASUS ROG Strix G15 and MSI, Katana 15. Then the lowest maximum frequency is the Dell Latitude 5490. So since the frequency is referred to the clock speed, so the higher the maximum frequency determines the higher the clock speed of the CPU. So the shorter the time taken for the CPU to process data and instruction at maximum frequency, and thus the higher the overall performance. Okay, so
This meeting is being recorded.
So now I will continue with the mini tools partition wizard, which compare the sequential and random writing speed and reading speed of the laptops. Okay. So the bar chart is show, first we'll talk about sequential. So sequential reading speed is this access pattern that refer to the speed at which the large file can be read from a device, while the sequential writing speed is referred to the speed at which a large file can be written to a device. So we can see from the bar chart, the ASUS Strix G15 always has the highest writing speed, while the ASUS ROG Strix G16 always has the highest reading speed. Except for high reading speed at 32 KB, and the ASUS ROG G15 had the highest reading speed at 16 KB. Then for the 8 KB, the highest reading speed is the MSI Katana 15, and for 4 KB, the highest reading speed is also MSI Katana 15. Okay, so now we move on to the random. Okay, for the random reading speed is this access pattern that refers to the speed in which a small pieces of data are retrieved or accessed by a device from a random location on the disk. So while random writing speed is referred to the speed in which a small piece of data or information is stored or saved to a random location on the disk. Okay, so according to the bar chart, for the writing speed, the highest is the ASUS ROG G15 for 4 KB, then for 8 KB is also ROG G15 for 16 KB, and for 32 KB, the highest writing speed is also ASUS ROG Strix G15. Now, if we look for the writing speed and the reading speed, for 4 KB, the highest is the ASUS ROG G16. Then for the 8 KB, the highest reading speed is from MSI Katana 15. And for the reading speed for 16 KB, the highest one is the ASUS ROG Strix G16, and for the 32 KB, it's also ASUS ROG Strix G16. Okay, so now we'll see the different execution times when running the SM code. Okay, so this is a table. So from the table, Okay, we'll see first for when the loop is 50, the lowest different execution time for the laptops is the MSI Katana 15. But when you move on to the number of loop 100, the lowest different execution time is Asus ROG Strix G60. So for 200 loop, the lowest difference of time is also the Asus ROG Strix G16. But when it comes to 500 loop of 500, the lowest different execution time is the MSI Katana 15. And for 700, the lowest different execution time is Asus ROG Strix G16. But when it comes to 1000 loop, the lowest different execution time is Dell Latitude 5490. Okay, so overall we can see the Asus G16 has the lowest difference in the execution time, which indicate the best performance among the 4 different laptops. Okay, this may due to the strong CPU, which the Intel Core i9 13980HX, which has 24 cores and 32 threads, which considered the strongest CPU among the all 4 laptops. So, however, we can see from the number of loop n equal to 1000, the Dell Latitude is has the lowest different execution times instead of Asus ROG Strix G16. Okay, this because in reality, okay, due to the high due to high power consumption and the high DP, so a continuous high workload will lead to a high heat generated, which might cause a gradual decrease in performance. So the difference in the execution time of the Asus ROG 16 is higher than the Dell Latitude at when n equal to 1000. So I think that's all from me. Thank you.
Hi everyone. So right now I'm going to continue with the task manager part. In this part, we are going to stimulate several work load subform, low load, middle load to high load to test the computer performance. We will use the task manager to record the performance of the computers and when stimulate different workloads. So for the low load, we choose to run Microsoft Word as the open Word editing applications to be tested. The memory consumption for the low load will be controlled between 30% to 50%. For the middle load, we choose to run the one web browser with several tabs that is working and Microsoft Visual Studio 2019 and also one Visual Studio Code. The memory consumption will be controlled between 50% to 60%. For the high load, we will run more applications from the middle load, for example, games or streaming apps, which will take a lot of memory consumption and make the memory consumption exceed 70%. As you can see here, there is some examples here. So right now, as I mentioned just now, memory consumption for the high load will be exceed 70%. With what? We will control it not more than 90% because when the memory consumption is more than 90%, the performance of a computer will start decrease. So in order to do so, we will end the task that has using the most memory and CPU in order to free some space for the other apps to be run smoothly. As you can see here, when the CPU and the memory is being used, that only have a less usage for the others, we will start to end the task with using the most which makes it able to return to the best performance it could. So for the low load, the CPU usage part, ASUS ROG Strix G60 has the lowest, which is 2%, and Dell Latitude 549890 has the highest of 9%. For the CPU seat, MSI Katana 50B12V has a lower speed, which is 0.89 GHz, and ASUS Strix G50 has the highest, which is 3.32 GHz. The Asus ROG Strix G50 shows a good performance with a high CPU speed and low usage of CPU. The Dell Latitude 5490 appears less efficient due to the high CPU usage, while the CPU speed is 1.32 GHz in the test. For the middle lot, the CPU usage of ROG Strix G60 is still the lowest, which is 4%, but the Dell Latitude 5490 has the highest, which is 30%. The CPU speed, MSI Katana 50B12V is still the lowest, which is 0.90 GHz, and ASUS ROG Strix G50 has the highest, which is 3.42 GHz. ASUS ROG Strix G50 maintains a good performance with a high CPU speed and moderate CPU usage in this test, while Dell Latitude 5490 still appear less efficient due to highest CPU usage with the CPU speed of 2.54 GHz, which is the third slow in the test. For the high load, MSI Katana 50B12V has a lower CPU usage, while Dell Latitude 5490 has a highest CPU usage that hits about 87%. The CPU speed, MSI Katana 50B12V still has the lowest, which is 1.61 GHz, and ASUS ROG Strix G50 has the highest, which is 3.89 GHz. ASUS ROG Strix G50 maintains a good performance like the middle test with a high CPU speed and second many CPU usage in the test. The Dell Latitude 5490 still appear less efficient due to higher CPU usage, again with the CPU speed of 2.41 GHz that is less than the middle test which is just now test. So overall performance we can get from the task manager. ASUS ROG 360 has a good performance but has a slightly low CPU speed than the ROG Strix G50, and ROG Strix 50 has a good performance overall with the higher CPU speed and balanced CPU usage. For the Dell Latitude 5490, it consistently shows a high CPU usage across all loads, which shows that it might suffer some difficulties when running in high loads despite moderate CPU speeds. MSI Katana 50B12V shows sufficient for low and middle loads but less capable under high loads due to lower CPU speeds, which makes it able to more suitable for the less demanding tasks.
This meeting is being recorded.
Hi, I'm Chojini. Now I'm going to present my own reflection. From this project, I have learned the computer performance for each computer is totally different, and they can be measured by using different benchmarking tools. Moreover, I also gained new insight on different computer specifications that will affect a computer performance. From the benchmarking tool CPU-Z, I can know the detail of specification for computer well. For benchmarking tool Geekbench, I can get the single core score and multi-core score for CPU and compete the score with other CPU. Moreover, from Task Manager, I can monitor real-time utilization of CPU and memory. For Mini2 partition wizard, I can know reading and writing speed for the SSD of a computer. From the ASM code program that I have written, I can react CPU elapsed time with the computer performance. In conclusion, from this project, I gain a deeper understanding about trade-offs between performance and cost of a computer and make the best decision when buying a computer that is the most suitable for my purpose of usage. Thank you.
This meeting is being recorded.
So now I'm going to present my reflection. So from this project, I've learned that there are many approach or method to use to measure the performance of the computer using various benchmarking tools. Like the benchmarking tool we use in this project, which is CPUZ, Geekbench, and Mini2 partition wizard. So besides that, I also learned that there are many factors or aspects that will affect the performance of the computer. So different specification of the CPU might affect the performance of the CPU in different way. So I've also learned that it is important to compare and inspect every specification of a CPU to make sure that the performance of the computer meets the user requirements. So I've also learned the difference between the random and sequential disk access pattern. Okay, and beside the pattern, I also learned that the difference between the reading and writing speed between computers or different specification and models. So for my reflection in conclusion, I think that the specifications of a computer is very important as it will affect the overall performance of the computer. So there are a lot of aspects that need to be considered when choosing a computer of suitable specifications to carry out a specific function at optimized or the best performance. That's all from me. Thank you.
So right now, allow me to do my reflection. In my point of view, by carrying out this project, we can know that benchmarking is the best way to evaluate computers' performance. By doing this project, we are able to use and understand the result of benchmarking tools. By studying this, students who study about the benchmarking could get the best computers suitable for their requirement. Performance of different computer specifications can vary and affect overall performance, so we will need more attention and choose wisely for this part. In short, benchmarking is the best way to choosing the best computer suitable for the user without spending too much on outrageous performance that might not be needed. Thus, we can spend every penny on the spot.
Hello, my name is Nazmi Kawin Khairul, and this is my reflection from the project. From this project, I learned the way to evaluate a computer's performance based on the CPU's characteristics. And then I learned the impact that these characteristics will bring to the overall performance of the computer. I also learned how to conduct benchmarks using a couple of free benchmarking software such as Geekbench, CPU-Z, and Mini2's partitioning wizard to obtain more in-depth information about the computer's components such as the CPU, GPU, and memory. In conclusion, I learned the importance of all of the specifications of the hardware components of a computer and how it can truly affect the performance of the machine.
So right now, I'm going to continue with the conclusion. For the conclusion, based on the result and the analysis we have conducted, it is apparent that these four computers have different processing power. So for the MOS test, computer 1, which is ASUS ROG Strix G60, computer 2, ASUS ROG Strix G50, and computer 4, MSI Katana 50B12V, have roughly the same performance, while computer 3, which is Dell Latitude 5490, gets completely demolished. In the CPU clock frequency comparison, computer 1 come out on top, followed by the computer 4. computer 2, and then computer 3. This position holds true for the most of the tests done through CPU Z, with only maximum frequency tests being the exception. Here, computer 4 comes out on top followed by 1, 2, and 3. This shows that computer 1 has the most powerful processor out of the 4, and computer 3 has the weakest processor. This comparison truly shows that all of the tiny details of the hardware components can and will have a huge impact on the performance of the machine. It also highlights the importance of hardware specifications, as it will also have an effect on the overall performance of the computers.